Okay, let's have a formal introduction to machine learning and understand the basic concepts or what machine learning is all about. Okay, so machine learning is learning from data or learning with data. So I'll draw an analogy here. Let's say we are trying to explain a child and trying to make him understand rate the concept of color and red color specifically. Okay, so let's see. Let's show the child this circle with the red color and tell him or her that this is red color. Okay, but what happens? Then we show the child this one. However, the child will also tell that this is red color because the child still doesn't have the concept of shape also. Okay, so how do we make the child understand that we are talking about color and shape, two different concepts? So we feed more data, that is, we show him another one and tell that this is blue and this is green. However, to make him now understand red, we show him different objects of red color and tell him that this is red and this is blue and this is green, and we continuously show him objects of this. Or if you wanted to make him understand that this is circle, then maybe we would show him different colored objects of this. So this is how the child starts learning either shape or color based on how we teach him. Now let's say what's the difference between what we have been doing so far, or how systems have been learning so far, or how we were building our software. So we have, it seems that this approach of feeding data and letting someone to learn can be applied to systems also. So we can feed the data with a lot of feed the system with a lot of data and let it learn by itself, which is contrary to deterministic learning, where we apply some sort of rules. For example, when a child, again I'll take the example of a child, when a child learns his or her mother tongue, he learns that intuitively. He listens a lot of language, he keeps on listening, and he understands where to use which word. But in a later phase of his life, when he tries to learn something, say a different language for job purpose or for any reason, he learns it more grammatically. He learns the rules of the language and he learns it through a process. So this second one was more of a deterministic learning, and the first one was learning with data. The child was continuously taking in data in his or her mother tongue and was learning it and was trying to make out the meaning and was adjusting the meanings, and this is a continuous process. So this is the same concept we apply for machine learning. Okay, so we feed a lot of data to the system and the system tries to find out pattern and learns what we are trying to tell the system. Okay, so there are various applications of machine learning, for example in image recognition, in computer vision, like face recognition, like it can identify or distinguish between two faces. Like language modeling, we can create the model of a language. We can create it grammatically also, but it turns out that we can feed a lot of language and annotate these languages and let the system create the language models. It works very good also if we can feed in a lot of language and the corresponding translated text in different language. Machine learning can be used to learn language translation. It can be built. It can be used to build chatbots to understand the context and respond accordingly based on the context. In various fields, it can learn fraud detection, whether something, some transaction or some person or some behavior indicates fraudulence or not, in a range or in a series of behaviors. Its machine learning is very much useful in search engines, where it can return the contextual search results or a specific. We can see the search engines of today, how they return accurate results, how they respond, give the specific answer what we are looking for, even when we do spelling mistakes, right? Also, it has a huge application for product recommendation on all e-commerce sites, on what you are looking for, on what you may be interested in. So it's you no longer need to search, but new items which you might be interested in comes along. Okay, recommendation of search, you might not be searching, but it can recommend you might be looking for this or that. Okay, in information retrieval, in extracting the information from unstructured texts. Okay, and then it can do sales forecasting, how much it can predict the future, it can predict the power consumption it might require in the future, or the sales, and various predictive tasks. It can do price prediction of certain objects in future. It can do sentiment analysis from a text, whether the text is written with a good sentiment, or whether it's a positive feedback, or whether it's a negative feedback. You don't need to write grammatical rules on words, but you can just feed and let the system learn. It can cluster your text, it can cluster the contents, like these are messages, are informations belonging to the same group, these news items. So these sort of tasks it can do. So let's see the broad categories. There are different other categories also, reinforcement learning and all those things. We will not go into those details as of now. We will see the broad categories in which machine learning can be classified. So let's see, first the machine learning, and from that we can classify them as supervised or unsupervised learning. Supervised learning is when we feed in the data with some labels, like suppose we are doing fraud detection and we feed in some transaction information and label it that this transaction was fraud and this was not, and from this data it tries to learn what are the behaviors of a fraudulent transaction, and later when a transaction comes in it tries to predict if it is similar to some fraud behavior or a real behavior. So we feed in some labels that whether the data was fraud or not, based on the business problem or based on the context of the problem. In unsupervised learning, however, we don't feed in any data, or sorry, we feed in data but we don't feed in any label. Okay, now first let's explore supervised learning in more details. There are two categories, one is regression based and one is classification based. Regression based is when you are trying to predict some continuous values, like say price of a house from the features. What can be the price of a house with the 2 bedrooms and 1 kitchen and 1 balcony, or 3 bedroom and maybe 4 years down the line, how, if we have the data, whether we can predict this. So price is a continuous data, whereas classification is more categorized data, whether it's good or bad, whether my house will get sold or not. Like this, always it can be multi-class also. Maybe we can predict whether this feedback is good, average or bad. Okay, 3 categories maybe. However, they can be any problem, some of the problems can be interchangeably put into regression and classification. So let's see the first problem that we saw, like identifying shapes, that is more, or the colors, that is a classification problem. And the second problem, sorry, this we have not discussed. Suppose we are trying to predict the salary a student would get from their marks. These are the marks of different students in different subjects. Okay, so you can see this salary will be in a continuous range. Okay, of course we can convert it to a classification problem by grouping these salary ranges, but this is a more of a regression problem. I have put it under the wrong column. This should go this way and this should go this way. Okay, so this is a regression problem, but again we can modify the data and treat it as a classification problem also. And then comes the unsupervised learning. You can see here different types of fishes. From looking at it, you can understand they are not labeled, right? The fishes are roaming around, but you can see the colors and the patterns. From these patterns, you can identify that there are 3 groups, right? So that is clustering. So this sort of problem where no labeling is provided explicitly to you, but you identify from the patterns and the behaviors that they are mainly under 3 clusters or 3 groups. That is unsupervised problem. Okay, so this was the basic. So this is all what are the techniques, what are the mathematical tools we have to do this prediction. We will find that out. Okay, in the form of regression or linear regression or logistic regression. Okay. Okay, let's also explore the concepts of matrices and vectors. And these are concepts from linear algebra, but we will not go much deeper into linear algebra, and try to understand matrices and vectors and why they're important for machine learning. Okay, so let's see. This is a number, and it can be a measure of anything. It's a single number, so this is normally called a scalar. Okay, now this is a list of numbers. What do we call this list of numbers? We can call it a list, but maybe these are numbers that belong to two different features of a same person. Maybe it belongs to the height and width of a square. Okay, so this is called a vector. Why do we call this a vector? Because it can be represented since there are two numbers, it can be represented in a two-dimensional space with a point. Okay, and this point has a direction. Okay, so 4 3 means 4 along x-axis and 3 along y-axis. Not necessarily from the origin, but we take the reference mostly from the origin. Okay, so basically it's a direction. So from anywhere, if it's 4 3 coordinate, it's 4 right and 3 top. Okay, so that's why when this point is represented, when this is represented in a two-dimensional space, we can represent this list in a two-dimensional space and it becomes a vector. Okay, now okay, it's gone. Let's see. Now what if we had three vectors? Okay, or three lists, which we are now calling vectors. What we have, if we had three vectors, we could represent them as 3 points in this. Okay, it's the one is the earlier point and 3 more, so 4 points in a two-dimensional space. Okay, now what if there were, instead of 2 coordinates, there were 3 coordinates? So we can represent them in a three-dimensional space now. It's each of these points, each of these vectors, which comprises of 3 coordinates, can be represented, or in our machine learning terms, they can be 3 features. So each object is now represented in a three-dimensional space. But as the dimensions grow, we cannot represent them visually, right? Okay, so what is this? So now if we stack these vectors, what do we get? We get a matrix. A matrix is you can consider it's not exactly, in linear algebra it's actually a linear transformation, but we will not go into that details now. We will consider this as a list of vectors, or if we consider that these are features of a single object and there are 4 such objects, if we combine them together and stack them, it creates a matrix. So matrix is useful in machine learning to represent data. Okay, so along the rows we represent the observations and along the columns we have the features. Okay, so normally this matrix will be called an m cross n matrix, where m is 5, that is the number of observation or the number of rows, and n is the number of columns, which is the number of features of each observation. Okay, and this is how we will work with data in machine learning. Now let's see. So this is our matrix. Okay, now what operations? We learn some operations on a matrix. Okay, let's see. This is a transpose operation. If you see, what is a transpose operation? A transpose operation is simply converting the rows to columns and the columns to rows. Okay, so if you see this column, this row here is a column here. This row is again a column here. So dimension of 1 2 3 4 5 cross 7, and this has a dimension now 7 cross 5. Okay, now the second important concept, which we have earlier also discussed in our basic statistics or the statistics prerequisites, it's actually a mathematical concept of dot product. A dot product of 2 vectors. Now each of these is a vector, right? These numbers represent features, and this is another vector. Okay, so what is a dot product? A dot product is simply multiplying them element wise and getting and summing over them. That is 1 into 4 plus 2 into 6 plus 3 into 7 plus 4 into 8, yeah, and like that, and we get the sum. If we sum them like that, and we get 198. So that is a dot product of 2 vectors. Okay, now let's see what's the dot product of two matrices. Okay, now we can consider a before going over there, we can consider a vector as a row matrix, right? That is a matrix with only one row, and if you rotate that or transpose that, you can consider it as a column matrix, that is a matrix with only one column. Okay, so this can be thought of as a matrix of dimension 1 cross 7. Okay, and if we had rotated that, it would have been considered to be a matrix of dimension 7 cross 1. Now a dot product between two matrices. To do the dot product between the matrices, the number of columns of the first matrix has to match the number of rows of the second matrix. This is the rule, otherwise we cannot do a dot product. So here you can see 1 2 3 4 5 6 7 7 cross 3, and the number of rows here is 3 cross 4. So 7 cross 3, and we do a dot product with 3 cross 4, and the results will be the rows of this matrix and the columns of this matrix. That is the number. The dimension of the output will be 7 cross 1 2 1 2 3 4 5 6 7 cross 4 1 2 3 4. So 7 cross 3 into 3 cross 4 gives us 7 cross 4. That is the dot product. And how do we do it? Here. So let's see. We take the first row, and here we take the first column, and we do a dot product between these two vectors and get this value over here, 40. Then we take the first row again and take the second column, and we do a dot product of these two vectors, 3 3 4 and 4 2 6, and we get 42. Okay, and similarly we get with this one and this one we get 24, and with this one and this one we get 16. Then we move to the next row here. So this one with this one gives us 89, and now we progress along the second row with each of the columns. Okay, so dot product is required to do of vectors is required to do a matrix dot product. Okay, now let's see why it's important in machine learning. So suppose let's look at a problem. So let's say our problem is we are trying to predict the future salary of a group of students from their current marks on 3 subjects in a college. These are the 3 subjects. So what we will try to find out here, maybe we have let's say we have discovered 3 weightages. So this is a matrix now, right? This is our input, and we are trying to find out these values, or these values are given. From this we are trying to learn and apply them with any other numbers that will be provided to us in future. So however, this is a matrix. Okay, and say we have 3 weights, W1, W2, W3, that is based on the number of features, and when we do this, we apply the weights to each of the subjects. That is W1 has a weightage, computer organization architecture has a weightage of W1, data structure has a weightage of W2, and OOPS has a weightage of W3, and these weightages are relevant for finding the salary. How? That W1 into 85 plus W2 into 80 and W3 into 87 will give us this value, or somewhere close to this, an approximation of this. Similarly, W1 into 90, W2 into 80 plus W3 into 92 will give us something close to this. So if you find these marks, we know how to predict the salary whenever these things are given. So if you look carefully, this is actually the dot product of this W vector with this. So what we can do is we can change this vector into a column matrix. Just rotated it, transposed it, and it's now a matrix of 3 rows and 1 column. And this is 1 2 3 4 5 6, because we have 6 observations and 3 columns, 6 cross 3 and 3 cross 1. So the row columns here match the rows here, and we can do a matrix product now. So 6 cross 3 and 3 cross 1 gives us, if we do it all together, it gives us 6 cross 3 and 3 cross 1. What does it give us? It gives us 6 cross 1. Okay, which is the dimension of this output. So in one go, using matrix multiplication, we can find the salary. Otherwise, what we would have to do is we would have to find the find the row wise product and sum, and we would have to do an iteration. So we get rid of the iteration using the matrix vector product. So this is something we will frequently use in our machine learning. Okay, I think these are the basic concepts, and if anything is required in future, we will also explore them. Thank you.